Hello and welcome to my YouTube channel Civil Line. Myself Milan Patel, Associate Professor at LJIET Institute of Engineering and Technology. Today's topic is about angular measurement. This is the third lecture of this topic. In the last lecture, lecture number 2, we have covered two topics, various terms related to angular measurement like meridian, declination, dip of a needle, and various lines, and measurements of bearings like WCB method, whole circle bearing method, QB method, quadrant bearing method, and RB method, reduced bearing method. In today's lecture, we will cover two topics. First, we will understand about what is forward bearing and back bearing, and lastly, we will cover various examples for calculation of interior angles. First, start with forward bearing and back bearing. So, what is forward bearing and back bearing? We will understand by figure. Suppose there is a line AB. For that, we have the compass or directions, north, south, east, west direction. This is the direction of the survey. Means we start our surveying from station A to station B and then station C. This is the direction of the survey. If bearing of the line is measured in the forward direction of the survey, it is called as forward bearing or FB of that line. If the bearing of the line is measured towards the backward direction of the survey, it is called as back bearing of the line. Here, theta 1 is forward bearing and theta 2 is back bearing. Because theta 1 is measured towards the direction of the survey, while theta 2 is measured in the backward direction of the survey. So, it is called as back bearing. For WCB system, if forward bearing of the line is less than 180 degree, back bearing can be found out by forward bearing plus 180 degree. If forward bearing of the line is greater than 180 degree, back bearing of the line is equal to forward bearing minus 180 degree. This is how we can convert forward bearing to the back bearing or back bearing to the forward bearing. This is for WCB system only. For QB system, forward bearing and back bearing are numerically same, but the quadrants are opposite. We will understand this conversation by number of examples. This is the example of conversation from forward bearing and back bearing. Suppose the forward bearing of any line is 140 degree. What will be the back bearing of that line? If forward bearing of the line is less than 180 degree, back bearing is equal to forward bearing plus 180 degree. Here, forward bearing is equal to 140 degree, which is less than 180 degree. So, back bearing is equal to forward bearing plus 180 degree. So, BB of AB is equal to FB of AB plus 180 degree. 140 plus 180 degree is about 320 degree. This is how we can find out back bearing from forward bearing. Second example, if forward bearing of BC is equal to 250 degree, the value is in WCB system. Okay, so the formulas for WCB system is used. So what will be the back bearing of BC? Here the value of FB of BC is greater than 180 degree. So for greater than 180 degree, back bearing is equal to forward bearing minus 180 degree. So back bearing of BC is found out by FB of BC minus 180 degree. 250 degree minus 180 degree is about 70 degree. Now let's see the next example. The FB of AB is equal to north 40 degree east. What will be the BB of AB? Here the value of FB is in QB system because the values is from 0 to 90 degree and having quadrants. Okay, so for QB system, FB and BB are numerically equal, but quadrants are opposite. So BB of AB is equal to value is same 40 degree, but the quadrants are opposite, north to south, east to west. Okay. Next example, if FB of BC is equal to south 58 degree west, what will be the BB of BC? Okay. So for QB system, FB and BB are numerically equal, but the quadrants are opposite. So value of BB of BC is equal to 58 degree same, but the quadrants are opposite, means southwest to northeast. Okay, the BB of BC is equal to north 58 degree east. This is how we can convert forward bearing to back bearing in WCB as well as QB system. Now, let's see our second topic of today's lecture, which are the examples of computation of interior angles. We will see first example. The details of observed bearings are mentioned below. Find out the included angles. Included angles means interior angles, and also correct the angles if needs to be corrected. Okay, we have to check after finding out the interior angles. Okay, the values of this FDM reading are from 0 degree to 360 degree without any quadrants. Okay, so this is the values of WCD system. First of all, we have to plot the traverse ABCD using FB of each line. Okay, we have the data. By using this FB of each line, we are plotting the traverse. Okay, this is the station A. First line FB of AB is equal to 20 degree 30 minutes. So 20 degree 30 minutes, one line is drawn. Okay, this is the station number B. From B to C, we have to refer FB of BC, which is 110 degree. Okay, 110 degree is in second quadrant, so line becomes like this. So this is the line BC. Now to go next, we have to refer FB of CD, which is 195 degree. 195 degree is in third quadrant, like this. So line is drawn like this. This is the line CD. Next, for drawing line DA, we have to refer FB of DA, which is 286 degree 30 minutes, which is in fourth quadrant, like this. Line is drawn. Okay, this is the direction of the survey. First, we will put our compass to station number A, then station B, then station C, and then station D. And lastly, we will come station number A. This is the direction of the survey. After this, we can check our traverse by drawing back bearings of each line. Back bearing of AB is equal to 200 degree, exactly 200 degree. Then back bearing of BC 290 degree 30 minutes. Back bearing of CD 15 degree, and back bearing of DA 106 degree. This is the whole traverse ABCD. This is how traverse can be made. Okay. After drawing traverse, we are going to calculate interior angles. Okay, by this table. This is the station ABCD. For station A, forward bearing line is AB, back bearing line is BA. Okay, from data given, forward bearing of line AB is equal to 20 degree 30 minutes. Back bearing of line DA is equal to 106 degree. The difference between two, 106 degree minus 2, 20 degree 30 minutes, gives the value 85 degree 30 minutes. Okay, the value of this difference is the interior angle. Okay, for station B, four bearing lines means forward line is BC, backward line is AB. The values of AB and BB are given in the example. We can find out the difference between them. Okay, the difference gives the angles. If the difference is less than 180 degree, most probably it is interior angle. If the difference is greater than 180 degree, it can be exterior angle. So we can judge by figures of traverse. Okay, by this we can calculate various angles. For station number C, forward line is CD, FB of CD is equal to 195 degree, BB of BC is equal to 290 degree 30 minutes. The difference is 95 degree 30 minutes. The value of difference is less than 180 degree, so it is interior angle. Okay, for station D, forward line is DA, FB of D is equal to 286 degree 30 minutes. Backward line is CD, BB of CD is equal to 15 degree. The difference between FB and BB is equal to 271 degree 30 minutes, which is greater than 180 degree, means it can be exterior angle. Okay, so we write this difference in exterior. To convert exterior angles into interior angles, we have to deduct exterior angles from 360 degree, because whole circle is about 360 degree. If the exterior angle is 271 degree, we can find out interior angles by 360 degree minus exterior angles. So interior angle 88 degree 30 minutes is achieved by 360 degree minus 271 degree 30 minutes. After calculating all angles, we have to find out the sum of interior angles. Here the sum of interior angle is equal to 359 degree 30 minutes. These are the calculation steps. Angle A is found out by BB of DA minus FB of AB, 106 degree minus 20 degree 30 minutes, 85 degree 30 minutes, which is interior angle. Angle B is equal to BB of AB minus FB of BC, 200 degree minus 110 degree, 90 degree, which is interior. Angle C, BB of BC is equal to BB of BC minus FB of CD. 290 degree 30 minute minus 195 degree 95 degree 30 minute, which is interior. And angle D, FB of DA minus BB of CD. 286 degree 30 minute minus 15 degree 271 degree 30 minute, which is exterior angle. To find out interior angle, we have to deduct this exterior angle from 360 degree. So 360 degree minus 271 degree 30 minute gives 88 degree 30 minute, which is interior angle. After finding out these whole angles or whole interior angles, we have to check and correct these interior angles. For checking the interior angles, we have to sum these interior angles. The sum of interior angles is equal to 359 degree 30 minute. The sum of interior angles should be 2n minus 4 into 90 degree. Okay, this formula is used for checking the interior angles. It should be here n is equal to number of lines or number of stations. Here n is equal to 4. So 2 into 4 minus 4 into 90 degree, which is 360 degree. So sum of interior angles should be 360 degree. Here our sum of interior angle is 359 degree 30 minute. So there is an error. So total error is equal to 359 degree 30 minute minus 360 degree minus 30 minute is the error. For correcting this error, the total correction is equal to plus 30 minute. Okay, so plus 30 minute can be added in the sum of interior angles. Okay, this correction is divided into number of stations. Here the stations are 4. So correction is divided into 4 parts. So correction per angle is equal to 30 minute divided by 4. Okay, it is 7 minute 30 seconds. 60 seconds means 1 minute. Okay, so here 30 minute divided by 4 means 7.5 minutes. 60 seconds is equal to 1 minute, so 30 seconds. 7.5 minutes means 7 minutes 30 seconds. So we have to add this correction per angle in all found angles. Okay, so angle A, calculated value is 85 degree 30 minute. After correction or after adding this correction, the corrected value of angle A is 85 degree 37 minute 30 seconds. Like this, we can find out whole angles A, B, C and D. After correcting this angle, the value of sum of interior angle is 360 degree. This is called as check and correction of interior angles. Now, let's see the another example. The details of observed bearings are mentioned below. Find out included angles, means interior angles, and also correct the angles if needs to be corrected. Okay. Here you can see the values are in QB system. First of all, we have to find back bearing of the lines, because without finding out back bearing, we cannot calculate interior angles of the stations. For QB system, fore bearing and back bearing are numerically equal, but the quadrants are opposite. We just discussed before this topic. Okay, how to convert fore bearing into back bearing. After converting fore bearing into back bearing, we have to plot the traverse ABCD according to fore bearing of each line. So first of all, we will convert fore bearing into back bearing. After converting fore bearing into back bearing, this is how table looks like. Okay, fore bearing of AB is equal to north 45 degrees. So back bearing is equal to, value is similar 45 degree, but quadrants are opposite. North to south, east to west. Similarly, we can find out back bearings of all lines A, B, B, C, C, D and E. Okay. After finding out back bearing, we have to draw a traverse. Okay. So by using this table, we will draw a traverse. Suppose this is station A. For drawing traverse, we have to use fore bearing of each line. So to draw line AB, we have to use fore bearing of line AB, which is north 45 degrees. Here, north, east, south, west direction are shown. Okay, so north 45 degrees is shown like this. Okay, this is how first line AB is drawn. This is the direction of the survey. To draw line BC, we have to refer fore bearing of line BC, which is north 75 degree east. Okay. To draw line CD, we have to refer full meaning of line CD, which is south 35 degree west, like this. Okay. This is the line CD. To draw DA, we have to refer FB of DA, which is north 65 degree west, like this. This is how traverse can be drawn. After drawing traverse, we have to input the BB values or back bearing values in the traverse. So back bearing of line AB is like this. Back bearing of line BC, south 75 degree west. Back bearing of line CD, north 35 degree east. And back bearing of line DA, which is south 65 degree east. This is how we can complete the traverse ABCD. After drawing traverse, we can calculate interior angles by using this traverse. Okay. First, we will find out angle A, which is shown by yellow sign. Okay. This is the interior angle A. Okay. So interior angle A can be found out by 180 degree because there are two quadrants. Total is 180 degree. Okay. 180 degree minus 4 bearing of AB, which is 45 degree, and back bearing of DA, which is 65 degree. So 180 degree minus 45 degree, 65 degree is equal to 70 degree. This is the interior angle A. Now next we will find out interior angle B, which is like this. To find out interior angle B, we have to use this type of formula. 180 degree minus 4 bearing of BC, which is 75 degree, plus 45 degree, which is BB of AB. So 180 degree minus 75 degree plus 45 degree, which is 150 degree, which is the interior angle B. Angle C, like this. We can find out by 75 minus 35. 75 is the back bearing of BC. 35 is the 4 bearing of CD. So back bearing of BC minus 4 bearing of CD. 75 minus 35, which is 40 degree. To find out angle D, we have to add these two values, 65 plus 35. 65 is the 4 bearing of DA, 35 is the back bearing of CD. So angle D is equal to back bearing of CD plus 4 bearing of DA. 35 plus 65, 100 degree. This is how we can calculate the interior angles of station A, B, C and D. After calculating interior angles, we have to sum these interior angles. So sum of interior angles is equal to 360 degree. Sum of interior angles should be is equal to 2n minus 4 into 90 degree. We have just discussed this. So here n is equal to 4 because there are 4 stations. So sum of interior angle should be 360 degree. Our sum of interior angle is also 360 degree, means no correction is required. These above value are the corrected interior angles. Okay. This is how we can find out interior angles in QB type of system. We are not drawing the table. Okay. We just referring the figure of the traverse. I hope you all understand these two topics, forebearing and back bearing, and various examples of calculation of interior angles in WCB system as well as QB system. See you soon in the next lecture. Thank you for watching. Don't forget to like, share and subscribe to my YouTube channel, Civil Line. Thank you.